we have skipped probability and we have jumped into what we call continuous distributions. So before we even start anything, we've got discrete and we've got continuous, and they're two different types of numerical variables. So what is how would you describe what a continuous variable is?
You measure it.
Something that you measure, and also you can keep breaking it down further and further and further. So you measure height, you measure weight, you measure volume, and if you kept breaking it down, you could keep going forever and ever into smaller increments. So we're going to look at continuous distributions and how to find probability within that. So we're not actually doing any component of the hard probability. This is the easier version of it with continuous. So there's two components to a continuous function in finding the probability. So another way to say continuous distribution is to say a probability density function, which you don't really need to know, but you do need to know how to find or how to discern whether something is continuous or not. So the first component is that, or the first fact about continuous distributions is that the area under the curve is equal to 1, like 100%. So if you added up all of the shaded area from left to right, that would equal 100%. And we're looking at portions of that. The second thing is that probability can be any number between 0 and 1. So the height can be anything between 0 and 1. You can never go over 100% chance of something happening. And you can never go under a 0% chance of something happening. So it's always going to be some sort of number between 0 and 1. There's two types of continuous distributions that we'll look at. And the first one, I actually have pillows to show you guys. These are finally when my pillows come in handy. So we have the uniform distribution that looks like this guy. We've kind of already talked about that shape. That's the first type of continuous distribution, and then the second type is a normal. So those are the two that we're going to look at today. The first kind is a uniform, which when I say uniform, I mean it looks just like a big rectangle. The same probability all the way across. So anytime you see a question where it says something has a uniform distribution, the first thing that you're going to do is draw a rectangle. And I think there is one drawn for you. I did not write out the example, so let's look at it together. So it says you have a friend that's always late. Let the random variable x represent the time from when you're supposed to meet your friend until he shows up. Suppose your friend could be on time, which would mean that they're 0 minutes late or up to 30 minutes late. So basically what you'll do is either the problem will give you the range or it'll give you the average time. So if it gives you the range, like this problem here, you're going to label the bottom of your rectangle 0. So that's when it first starts, up to the maximum time that your friend is late. So your friend could be anywhere from 0 to 30 minutes late. So the bottom of your uniform distribution, that'll be your minimum. And then the point on the right, that'll be your maximum. If it ever asks you, and I don't think it asks you in this problem, but a uniform distribution, would you consider that to be symmetrical as well? Yeah, it's symmetrical. So that means that in the center, what's the middle of 0 and 30? 15. That would be considered my mean and my median. So sometimes it'll give you that. Also from this, I could also say my range is what? 30, because it would be 30 minus 0, which is 30. the last thing that we need is our height. So my height is equal to 1 over my range. That's the height of my distribution. So I want you in your calculator to type in 1 over 30, and you can leave it as a fraction or you can put it as a decimal. Either one. So when you type in 1 divided by 30, what do you get? 0.03 repeating. So I'm just going to put 0.033. And you can either leave it as a fraction when you're solving a problem, or you can put it into a decimal, just go out 3 decimal places. So now you have everything you need to answer the problem. And when it asks you a probability question like part A, essentially what you're doing to find the probability is you're calculating the area. And the area of a rectangle is what? Base times height. But yes, the total, that entire rectangle would be 1, but I'm just going to be looking at like individual components of it. So part A, it says, what's the probability that your friend is between 10 to 20 minutes? So basically anywhere from here to here, I want to figure out what's the probability of that happening. So I'm going to take my area is base times height. What would my base be from 10 to 20? What's the range of that? 10 times my height, which we've already established is what? 0.033. And so what do you get? 0.333. So the way I would interpret that is there is a 33.3% chance that your friend will be between 10 and 20 minutes late.
So would you do a percentage or would you keep it in decimals?
Just leave it in decimals. Yeah, it's easier to leave it in decimals. Part B, it says, what's the probability that your friend is between 3 and 9 minutes late? So anywhere from 3 to 9.
So it's 6.
So I would take, what's my base? 9 minus 3 is 6 times 0.033. And what do you get? 0.2.
Yeah.
What'd you get, Hunter?
I got 0.198.
But then you round.
0.198. What's the fourth decimal?
Yes.
Oh.
There's no one.
Did-
Mine has 0.1999.
Do it with the original.
It depends on if you did.
Do it with the original and it's 0.2.
I would accept either one. If you use 0.033 or you use 1 over 30, doesn't matter.
Oh, okay.
Either one.
Figure out that that's 6 beside that.
If you're wanting it to be exact, which I think is more accurate, especially once it comes time to taking the exam for this class, I would use either the fraction, or you could go, like if you hit the up button and select the number, it'll type it in. So just try to do the most exact one. Okay, the next one says less than 13 minutes late. So anything less than 13 minutes includes 13 and then below. So my base would be what there? Times 0.033 repeating. 0.433. And the last one says probability that it's over 25 minutes. So 25 and above would be 5 times 0.033 repeating. What do you get? 165. So the whole point of this is to find the area under the curve. That's essentially all that probability is area under the curve. And in this case, when you have a big rectangle, the area under the curve is just base times height. So I want you guys to try example 2. So you're going to have to draw the rectangle. I want you to label the minimum, the maximum, and the height. So those are the 3 things that you need. And then answer parts A and B. So for the first one, it was 0.75, and then the second one was 0.25.
Wait, why is it 0.75 on the first one?
Because if you take the area, or like the length of the base, so basically the distance from 6.75 all the way to 7.5.
I went that way.
Oh, because it says at least, and
Oh.
at least is greater than or equal to. So 6.75 and everything above it. Okay, questions about number 2?
I'm kind of confused how you got the 0.75 and 0.25.
So it's just the length of, like the distance from 6.75 to 7.5. So I take 7.5 minus 6.75. And that's how I get my base for that one. On the second one, it's just the distance from 7.5 to 7.25. So your base is just like that width. So you'll basically just be taking max minus min, whatever your lower bound and upper bound are. All right, let's look at example 3. So this one says the weather on a tropical island in January is fairly constant. Records indicate that the high temperature for each day of the month tend to have a uniform distribution. So I want you guys to circle that. There will come a time where we're going to mix the 2 together, and you're going to need to identify which one it's asking you for. So uniform with a range of 15 and a maximum of 90. So I'm going to draw my rectangle. It tells me that the max is 90, and what would go on the lower end? 75. How come?
Because it's a range of 15.
Yeah, a range of 15. And then my height would be 1 over 15. And I don't know what decimal that is. 0.066 or 7. Oh, 0.066 repeating. Let's try to keep it as the full decimal when we're solving. Okay, so now that we have it drawn, I want you guys to try parts A and B by yourself. Just remember, so when we add into normal, it's going to be different, but remember with uniform, base times height, make your rectangle. So let's look at the second type of continuous distribution, which is the normal one. And so far, all we've done with normal distributions is the empirical rule, where you went out 68, 95, 99.7. But we're going to look at today what happens when it doesn't fall exactly on those lines. Like, what are the in-betweens? So just to recall a little bit, remember that on this axis, this x-axis, are z-scores. If you have a positive z-score, what does that mean? That you're above average, and if you have a negative one, you're below average. And a standard normal curve is when you go out 1, 2, 3, down 1, 2, 3. So there's 3 essentially on each side. We're going to use our calculator today, though, to solve for the area under the curve. So if it's asking you, and you'll see it kind of written like this, and how I would interpret it. So for A, the way I would say it out loud is I would say probability that Z, or that the Z-score is greater than 2.45. And so far we know, all we know is greater than 2, or when it's an exact number. Greater than 1, greater than 2, greater than 3. When it falls on a whole number. But we don't know, like, the stuff in between. So I have these normal curves off to the side because it really helps to visualize, like, what am I trying to find here? So 2.45 would probably be somewhere around here, and it doesn't have to be exact. So I'm going to put 2.45, and do I want the shaded area above that or below that? Like to the right or to the left? To the right. So I want to figure out what is this area that is above 2.45. So in my calculator, you are going to go to second, vars. And if you can't find vars, it's next to the clear button. And then you're going to scroll down to option number 2, which is normal CDF. Never choose option 1, PDF. It's going to give you 0 every time. I don't even know why it's on the calculator, but it is there. But we always use normal CDF. Hit enter, and you should be given these things. Like, it should be a screen that looks like this. If anybody's calculator does not have a screen like this, then I need to update it for you. So come see me after class and I will help you. So it's asking for a lower bound and an upper bound. Basically, the lower bound is where it starts. The upper bound is so the left side of the shaded area to the right side of the shaded area. So in this case, or in this example, our lower bound is 2.45. From there, I'm shading all the way to the right. So I'm shading all the way to infinity. Okay? And how I represent infinity, the easiest way for me to do it is just to think of a really, really, really large number. So I'm going to say 2 to the 99th power. So 2, I'm going to choose this little caret button right here under the clear. 99. And that is infinity, pretty much. I mean, not really, because infinity is forever. But it's the biggest number possible. And I'm going to leave my mean as 0 and my standard deviation as 1. And we don't ever touch that for right now. We'll change it later, but right now, our mean is always 0, our standard deviation is 1. I hit paste, and then enter again, and this is my probability, 0.007, 0.0071. So what I want you to write for your answer, because you're going to be asked to show your work, which is basically just typing in what you put in the calculator. So what I want you to write is not just the answer. I want you to write normal CDF, your lower bound, your upper bound, 0, 1, equals 0.007. So that would be equivalent to how you show your work for this kind of question. Do what?
007.
007. So it says the probability that Z is less than 0.39. So I'm going to say 0.39 is somewhere, actually it's going to be on the right side because it's positive, but it's going to be close to the middle. And do I want to shade to the left or to the right of that? The left. So now my lower bound is going to be negative infinity, whereas up here, the upper bound was positive infinity. So I'm going to go back to normal CDF. Now my lower bound is negative infinity. So I'm going to say negative 2 to the 99th. My upper bound would be what? 0.39. And then I leave my mean and standard deviation as what?
0 and 1.
0 and 1. And tell me what you get.
65.
So 0.65. Is there a third decimal place?
1. Or
1.
2.
2. And this makes sense because if you look at my picture, that's over half. Because if I'm shading it to the left, if it were directly in the middle, like at the 50th percentile, or a mean of 0, then it would be 50%. So I'm shading over half of it. So you need to evaluate, does my answer make sense? On part C, this one gives me a lower and an upper bound. So it's somewhere between negative 0.25 and positive 0.25. So in this case, will I need to use will I need to use infinity or negative infinity in my answer? No. So I would type in normal CDF, and my lower bound would be what? Negative 0.25, and my upper bound would be positive 0.25. My mean and standard deviation are what and what? 0 and 1. Good. And what do you get? 0.197. Okay, then I want you to try part D. Okay, so what did you get for part D? 0.67. Does that make sense? Because is it more than half that you've shaded? Yeah. So lower bound would be negative 0.45 and then 2 to the 99. The last part is going the opposite way to where it gives you the area under the curve and it's asking you to find the z-score. So this would be an example of where we use inverse norm in our calculator. So basically what it's asking for is it's asking for a z-score and it's giving you the percentile or the area. There's two ways though that it could ask you that. So if you look at E, it's saying what z-score has a shaded area less or 60% is below that z-score. So the way I would interpret this is 60% below what z-score. So basically what z-score is at the 60th percentile. Which, do you think you're going to get a positive answer or a negative answer?
No,
Positive, because you're going to be above the 50th percentile. So in my calculator, I'm going to pull it up here. I'm going to hit second vars again. Second vars. And now I'm going to go to option number 3, which is inverse norm. And for area, I'm going to put in 0.6. Then you'll leave the mean and the standard deviation as 0 and 1.
The tail.
Leave it as left, always.
That's always
Yeah, don't ever change that. Hit paste. And my z-score is 0.253. 0.253.
Do we have to show work on this?
Yeah, so for this one, we're going to show our work. So we're just going to put what we typed in the calculator, which would be inverse norm 0.6001, and you got 0.253. You guys don't have a normal curve on yours, but it doesn't hurt to draw them just to visualize, because sometimes when you do this, you get a really wacky answer and blindly you'll just put it down, but you need to evaluate, does my answer make sense? So in this case, yes, it does, because it should be positive. What F is saying, so you notice how the signs are different. One is less than, one is greater than. What this one is saying is that 28% is above that z-score. So if 28% is above, then how much would be below that z-score? Or what percentile am I looking for? If 28 is above, how much is below? 72. So I'm looking for the 72nd percentile. Because the greater than means above. So 28% is above. But when you're doing inverse norm, you need to put in the percentile or the area that is below. So I would do inverse norm 0.72, 0, and 1. So when it's a greater than sign, you're basically doing the opposite or the complement of the number it gives you.
So it'd be 68.68.
0.72.
Or sorry.
Yes.
Whoops.
So what do you get when you type in 0.72? 0.584 or 583? 583?
583.
It rounds to 3.
Okay, G is written a little bit different. So it says find the z-score that represents the top 10% of the data. So top 10% would be at the what percentile? 90th. So inverse norm of 0.9. So what do you get when you type that in? 1.282.
You said the tail for that part, is it left, center, or right?
Use keep it at left. That should be the default.
Okay.
And then H, it says find the z-scores that separate the middle 80% of the data. So if basically if 80% is in the middle, how much is on the outsides?
So 20 and then
10 on each side.
Yeah, 10 on each side, right? So there's 10 on this side and 10 on this side. So you can type in one of two things. The percentile on the lower end is the what percentile? Not the 20th, the 10th. And then the one on the upper end is the what percentile? 90th. So you can type in either one, but for this example, I want you to type in both just to show what happened, and then you'll see.
Like the normal CDF, is that what you're saying?
No, you're going to use inverse. So if it ever says find a z-score, you're using inverse norm.
Oh,
If it says find a probability, that's when you do normal CDF.
okay.
they're just
So what did you get for the 10th percentile?
-1.282.
And then what did you get for the 90th percentile? 1.282. So when you see a question like this, if they are like mirror images of each other from the middle, they're going to be the same z-score, but one will be positive, like the lower one will be negative, the upper one will be positive. So you really only need to find one, but your answer would be both of them. It doesn't hurt to type in both just to make sure you did the right thing. But how I got the 10th and the 90th is you can take 100% minus 80%, and that gives you 20. Then you cut that in half. So you get 10. So it's 10 on each side because it's taking the area left over and splitting it on each side. So you can just use that as a rule of thumb for every one. Like if I said the middle 70%, then there would be 15% on each side.